All right, hello everyone, and thank you for joining us for today's webinar on running your Kubernetes cluster behind the firewall with the Codefresh Runner. Our presenter today is Guy Salton, Solutions Architect at Codefresh, and he's going to show you how to run Codefresh auto-scaling pipelines, specifically on Amazon EKS for his demo, and how the Codefresh Runner works out of the box, automatically taking care of everything for you, no plugins, updates, or dependencies required.
Thank you very much, Taryn, and welcome everybody. Thank you for joining. I'm glad to see both Codefresh users and people that still didn't get a chance to play with it. So today we're gonna focus on how to run Codefresh pipelines, CICD pipelines on Amazon EKS clusters with autoscaling, and we'll see exactly what this means. A bit about myself. My name is Guy Salton. I'm a solutions architect in Codefresh. So I work on POCs, I help with technical questions, workshops, and also do webinars and blogs sometimes. You have my email address there, so feel free to send me any questions or comments, notes, issues, whatever. Would be happy to talk. So a bit about today's session. So for CICD, I guess that most of you are familiar with the concept, and especially for enterprise companies, you need to sometimes access internal assets that are behind your firewall as part of a CI/CD workflow, right? So sometimes the actual Git repositories are hosted in an on-premise instance inside your network. Sometimes you have a Docker registry that is hosted behind the firewall. You may have a Kubernetes cluster that you need to deploy applications to or pull secrets to, and it's also not publicly accessible. So these are very popular use cases. And maybe just zoom out a bit about the continuous integration delivery processes for those who are not fully familiar. Just to shortly explain about this. So CI and CD, right, they're two terms that are basically defining the modern software development lifecycle, where starting with the CI, developers push their code, it goes through compilation, packaging, testing, and then once the new code is packaged and ready to be deployed, it's moving into the continuous delivery, continuous deployment side, where the application can be deployed to different environments, starting from lower environment, testing, staging, and then finally to production, where users can access our application. And with Codefresh is a CI/CD platform built specifically for microservices and Kubernetes. And it is the standard offering is a fully SaaS cloud-hosted platform. This means that once you sign up to Codefresh and you start running pipelines, you can just run pipelines without installing or maintaining anything in your network. But this means that your builds will run on some cloud-hosted cluster that we host, right? And then comes the question, well, what you need to do if you need to access any internal assets, like we discussed at the beginning. So again, a bit about Codefresh. With Codefresh, as I said, it's built specifically for containers and microservices. Each step in the pipeline will actually run as a Docker container. So the actual cloning of your repository, running the build, running different tests, performing the deployment, each of these actions will run in a container. We have built-in support for Kubernetes and Helm deployments with complete traceability between the code and the actual deployment. So both CI and CD aspects in the same platform. And again, to emphasize again that the use case is why you should go hybrid. When I say hybrid, I mean, and we'll see exactly the Codefresh offering for that, but meaning that working with a SaaS cloud-hosted platform, but still running your builds behind the firewall, right? So common use cases can be you need some behind firewall resources for the build, right? So let's say you need to access any secrets, artifacts. The actual source code might be behind firewall, and you need to access it as part of your CI/CD pipelines. Also for deploying behind firewall, right? So sometimes you would have Kubernetes clusters, VMs that are not publicly accessible, and if you want to be able to deploy applications to these clusters, you need access and to be able to access them behind the firewall. So how would you do that? And I think this is one of the interesting solutions, because there are open source CI tools like Jenkins, for example, right? And then and this means that with Jenkins, of course, you can run your builds on your own infrastructure, but then you also have to maintain the whole platform and the whole tool and all of the management also on-prem. So customers that choose hybrid, they usually want three main things. They want to be able to scale and easily scale into running multiple and more builds in parallel. They want the security aspect, and this we already mentioned, right? To access internal assets behind the firewall, like source code, artifacts, secrets, clusters, etc. But the management part is also very important, because I think companies today realize that maintaining everything on-prem just takes a lot of time. It takes a lot of maintenance and management. You know, companies want to be able to use SaaS platforms, but they still want you know, to maintain a secure environment. So how would you do that? So that's why we introduced the Codefresh Hybrid Runner. The Codefresh Hybrid Runner means that you can still sign up to Codefresh SaaS platform, right? So Codefresh, as I mentioned, is a SaaS platform for CI/CD. You can go to codefresh.io, sign up for an account. It will create an account for you, and you can manage all your accounts, your integrations, your pipelines, your users, everything like that. But then install the Codefresh Runner, which is basically an agent that can be installed on any Kubernetes cluster, and you can install it on your own cluster inside your network, right, behind the firewall. And then you can configure any of your pipelines to run on your own cluster. So this way, if you have any secure Git repos, secure Docker registry, and Kubernetes cluster, things like that are behind the firewall, then you can just run your pipelines on this runner, meaning they would run on your own cluster. Then it would have access to any of these internal assets. But still, still you don't have to maintain the whole platform on-prem, right? So only the builds run on your cluster, and the whole platform and the whole account management is still managed in the cloud, meaning that also every new improvement, new features that we release, you get them seamlessly, right? As if you compare this to fully on-prem solution, you have to maintain everything yourself. Every new version has to be manually sent to you, then manually installed. The whole release lifecycle and management of the platform is a bit of a pain. So here it's kind of the best of both worlds. One more thing to note is that you don't need to open any inbound ports, right? So you see this arrow pointing to the public internet, to the Codefresh SaaS platform. The runner works on with polling mechanism, so you only need outbound connection to Codefresh. You don't need to open any inbound ports, and then the agent would just pull tasks from Codefresh and execute them on your own cluster. So this runner, as I mentioned, it runs on Kubernetes. It can be installed on any Kubernetes cluster, including Minikube, Docker for desktop, and of course EKS that we're going to show today, but any other cluster. Only unidirectional communication, as I mentioned, no need to open ports, and it works with polling mechanism. So let's jump into our first demo, installing the runner on your, and I'm going to install it on my own laptop, actually, on Docker for desktop cluster. So let me quickly switch to my terminal here, and I can see that, yeah, the current context. Let me quickly change it to my Docker for desktop, and I see that this is my cluster here, right? And I can go and see any namespaces that I have. It's it's a super basic cluster with basically nothing on it. Right now, to install the runner, I need to use the Codefresh CLI that you can install on any machine. Doesn't matter if you use Linux, Mac, Windows, can install the Codefresh CLI, and then you can just run the Codefresh Runner init command. And this would take you to a wizard to install the runner on your account. Note that you first need to authenticate the CLI to your account. I already did that, so I don't need to do it. It would then ask me which cluster I would like to install the runner on. I'm going to choose the Docker for Desktop one. Then it's going to ask me which namespace I would like to install it on, and I can just create a new namespace. I don't have such a namespace, but it will create it for me. And then it asks me if I want to change the default runtime to this new runtime. I'm going to say no. And just so you know, and we'll see this very soon, you can create multiple runners and then manage multiple runtime environments in Codefresh. So I already installed one runner on an EKS cluster, and this is currently my default runtime environment. I'm not going to change it for now. Just going to install a new one after here on my desktop. And it asks me if I want to run a demo pipeline. I'm going to say yes. And now let's see what's going to happen. So you see, it tells me the summary. This is the cluster that I'm going to install the runner on, the namespace. I won't set it as my default runtime environment. And I asked to run a demo pipeline after the install. Then the installer will do everything, and it will kind of nicely detail this in the logs here. So it will go and create a runtime environment for me in Codefresh, create an agent for me and all the necessary configuration, then attach the runtime to this agent and run a dummy demo pipeline in my Codefresh account. So it's actually starting the pipeline now. You can go to my Codefresh account real quick, and I see that a build is now starting. Right, so this is just a very simple build that will start on my cluster, and I can quickly go and then run kubectl get pods on my new namespace, and you see that 29 seconds ago, a new pod of type din just started. So this is how we run our pipelines on Kubernetes, right? We just start a new pod of type din, Docker in Docker pod, for those who are not familiar. And then all of the steps in my pipeline will run as containers inside this din pod. So you see that I can see the output of my new build here in the UI, and it will then go and just run a simple step that will output something to the standard output. And once this is completed, this din pod will be terminated, and the build will be completed. So yeah, it then, just as the initial kind of first time running the build, it will pull some necessary Docker images, and you see it printed hello, and then my pipeline finished completely, properly. And then if I go, I see that this new din pod is now being terminated, and it's it will then disappear. So this is how easy it is. You saw I just did it with you from scratch, just a few minutes to install a runner and run a pipeline on your own cluster. So this was kind of like a very basic scenario, right? Just installing the runner, it just ran a super simple pipeline on my actual cluster. And I see that this din pod is now terminated. Now, let's go back to the presentation and see a more advanced and interesting scenario. So this was a bit like a high-level architecture diagram of what we just did now, right? Running pipelines on my Docker for Desktop cluster. So I had installed the runner. The runner then communicated with the Codefresh SaaS platform, and it created this demo pipeline. Then the runner pulled this new build as a task and created a dint pod that run my build. So that was the first demo. Now, let's see a more advanced kind of scenario while installing on EKS with autoscaling. So let's go back to the browser here. I'll go back to the account and I'll just show you, for those who are not familiar with Codefresh, right? This is the Codefresh platform. Again, you can just go to codefresh.io and sign up for an account. And then you have this sidebar on the left-hand side, and you can go and create projects and pipelines and builds. Then I'll also show you a few of these dashboards here, the DevOps Insights. This is where you can manage any Kubernetes deployment, Helm releases, manage environments, perform rollbacks, and cool stuff like that. And more focused on the CD part, right? As I mentioned, Codefresh is both a CI and CD platform. And you can even manage all of your build artifacts like Docker images from any Docker registry inside Codefresh. So what I want to show you now is I'll go to the account settings. I'll show you some of the things that I connected here in my account, and then we'll run like a proper CI/CD flow of a containerized application. We will run it on EKS, and we'll see how it works out of the box with autoscaling. So here in the integrations, you can connect any integrations to your account. I went and connected the GitHub integration, and I used just github.com, a cloud-hosted one. But for every kind of integration like this, it doesn't matter which Git provider you're using. We're completely Git agnostic, right? So if you want to use Bitbucket or GitLab or GitHub, for any of these options, we support both the cloud option and if you have an on-premise or even behind the firewall Git instance. And then, of course, this is the whole kind of idea of this webinar, right? To explain how your builds will be able to access any secure Git repos. For example, so it works nicely with the runner, right? Because then if I install this runner on my EKS cluster, this EKS cluster is in the same network as this Git instance, then while running my builds on my own EKS cluster, it will be able to access any secure Git repos. And this is true for any other integration here. So you see, I actually went ahead and integrated my ECR registry. You can connect any Docker registry to your Codefresh account if it's ECR, Docker Hub, GCR. You can also use any other registries like Nexus, Quai, Harbor, Artifactory, anything like that, with just providing your credentials. And then you can also set it as installed behind firewall. So I'm going to use ECR for my demo. Then for connecting a Kubernetes cluster, I connected my EKS cluster here, but you can connect any kind of cluster. It can be GKE, AKS, DigitalOcean, but also any on-premise cluster like OpenShift, Rancher, whatever you use. The integration is based on a Kubernetes service account. I won't elaborate a lot on this. And there's some other integrations here. Again, this is not the focus of this webinar. One more thing that is usually very important for companies that needs to run CI/CD workflow behind the firewall is secret management, right? So like in probably every other CI platform, Codefresh also had this shared configuration option where you can add any config files or credentials, tokens. You can set them as encrypted variables, and you can then easily import them into your pipeline. However, these will still be managed in the cloud. So if you want this additional layer of security, we recently released this new feature called Secret Store. And this lets you pull any secrets from your own Kubernetes cluster that are stored as a secret or as a config map, and then seamlessly use these secrets as variables in your pipelines. So as I showed you, I connected my EKS cluster, and I then created this secret store integration to use my NPM secret that is stored in the CF namespace in my cluster, right? So I can quickly jump to the cluster and show you that if I run the kubectl, and maybe enlarge this a bit. If I run the kubectl get secrets npm in the CF namespace, where it's not this, because I'm in the wrong cluster, right? Let me switch to my EKS cluster and run this command again. I see that I have a Kubernetes secret here, and it simply has one key and value, right? Let's say like an npm token. So I stored it here, and then I'm going to use it in my actual build. And I can see any agents running in my account. So I have the Docker for desktop agent, and I have the EKS agent that I installed. And I can then go and show you my pipeline that will run an actual build on EKS. So I created this pipeline here for a Go application that I use for demos. So just to quickly go over the flow with you, I'm going to commit some change to my repo. This will start a build on my EKS cluster. And we can actually see it quickly here. So I can go to my AWS account. I see that I have this EKS cluster version 115 here in Ohio region. And I can go and see any of the nodes associated with this cluster here, right? So I deliberately created 3 node groups. One I called my EKS DIND. It contains of 1 M5, 2 extra large instance, and this is for running my actual builds. Then I have the engine node. The engine is the component that will start the builds. It will go and start the DIND pod. And I have an add-on node, and this is for the scaling. So when I created this cluster, and I can quickly show you, and we have this pretty nicely documented. If you go to codefresh.io/docs, under administration, you'll see the Codefresh Runner documentation. It's a new feature. It goes and explains exactly how you would go and install the runner, and actually seen this section, right? So installing the Codefresh CLI, I did this before the webinar, doing the authentication, and then running the Codefresh Runner in it. But if you scroll the way down here, you actually see a detailed explanation on installing to EKS with autoscaling. This is what I did. You can just simply follow this process. If you're using EKS, it works, of course, with any kind of Kubernetes provider. So you do the same with GKE, but basically I used EKS CTL to provision a new cluster. And then I assigned these node groups to my cluster. And I then set the autoscaler parameter to true, okay? Then create the cluster. I went and deployed the cluster autoscaler in the kube system namespace, added this annotation to the autoscaler deployment, and then just added a few of these commands here under the autoscaler deployment, like skip node with system pods. I also configured, and I'll show you this in a second, scale down configuration, and then set the image to the relevant version of my cluster. So I'm using 115 for the cluster, and I use 115.6 for the autoscaler. So if I go and quickly look at my cluster, and you see I changed the current context to my EKS cluster, I can see my nodes, right? And I can then go and see my namespaces. And I have this CF namespace. This is where I'm going to run my builds, right? So if I go and run pods-n CF, I don't have any DIND or engine pods running, right? Because I don't have any builds running now. But once we start the build, then we'll see the new DIND pod spinning up in this namespace. And I have here in the prod namespace, this is where I'm going to deploy my Go application to. And so let's go ahead and make some change to my application. We go to the repo of my app. This is my Helm, my Go demo application. Go to the source. And I can then go and look at my Go file here. And this is super simple Go web server that will just print this line to the browser. I can go and make a change, and let's just add like an exclamation mark here, save the changes, add the file, and then add a commit and say, okay, adding like this, and oh, sorry about that. It doesn't like the exclamation mark. Adding, like, let's say, changing source code or something like that. And I'm gonna then push my changes. And then this push will then trigger a build in Codefresh. So if I look at builds now, I see that a new build just started, right? I configured my pipeline to have a trigger that will run for every commit. Now I can go and open my terminal, and we can try to see this like side by side. And I'll just run the get pods command on the CF namespace. I see then a new dint pod running 25 seconds ago. I can actually exec into this pod just to see what's happening behind the scenes. And I'll take the pod name, and I can then run watch and docker ps, and this will show me the containers running, right? So each of these steps will run as a container inside the dint pod. So it built my image. It will then run some tests. This is the image that is currently, the container that's currently running, and then the actual deploy will also spin up a new container. You see it's called CF deploy Kubernetes, and my pipeline is actually completed. Now, one more thing that I want to show you as part of my pipeline, we didn't really talk a lot about the actual workflow definition, but you see that a pipeline in Codefresh is built using declarative YAML, right? So you can just build this YAML inline like I did here, but you can also store this YAML file in your Git repo and then manage it under version control. And then to build the pipeline is actually pretty simple. No need for scripting or code or bash or anything like that. You have all of these built-in steps on the right-hand side, and you can easily add them to your pipeline. So to clone a Git repo, you can just go and click on clone a Git repository, copy this, paste it here in your YAML. Then we have a built-in step for building Docker images. So you don't need to even run Docker commands explicitly. You just go and copy the build the Docker image step, and you just specify the type of the step as build, point to the Docker file that you have in your Git repo, choose any image name and tag, and you can even add a registry to this step. So what will happen is that this step actually has some really cool caching optimizations that are made to it, and it's using out of the box. So I actually set my ECR registry as the default registry and the internal caching registry that I'm going to use. And every time then when this step is running, it's going to build a Docker image, but then also automatically push it to my ECR registry. Then the next time I run the build, it will automatically use the image from the cache if nothing changed in my app. But even if I did make some changes to the Docker file or to the app, it will automatically use any existing layers from the cache and only build new layers. It has built-in out-of-the-box distributed layer caching. You can then add any annotations to your Docker image, and we'll see how we nicely present and that you manage your Docker images from Codefresh. Then actually in the test step that I'm going to run after building my image, I'm going to echo out this secret that I store in Kubernetes. So meaning that, as we saw before in the secret store integration, you don't need to manage your secrets in the cloud and be exposed to security vulnerabilities or concerns. You can just easily use this syntax to pull any secrets from Kubernetes. I'm going to pull this NPM token, and I can then use it in any step. And then finally, to deploy my application, we have a built-in step for deploying applications to Kubernetes. Again, completely declarative. Just choose the cluster that I want to deploy to, the namespace, the service, and that's it. So what I want to do now is show you the autoscaling part, right? So for every pipeline in Codefresh, you can choose where it will run. So if I go to the settings here and then go to runtime, you see that it's currently running on my EKS cluster. Having said that, I can change and run different pipelines on different runtime environments, right? So let's say I have some IoT device that I want to run a build for. Codefresh has support for ARM architecture, or you want to run like a Windows container, then we also have Windows container support, and we can allocate such an environment to your account, or Mac OS builds, or let's say you just have some pipelines that don't need to access any internal assets and you don't really need to run them on your own cluster. No problem, you can just run them on Codefresh SaaS runners, right? Instead of using your own. So this way you can have different pipelines running on different environments. Now, if you noted, the deemed node, that I'm actually going to run my builds on is instance type M5 2 extra large, right? So it has 8 cores of CPU, and I only have one of these, right? So what I want to do now, you see, I can change the amount of resources that I want to allocate to any of my builds. So I set my build to take 7 cores of CPU. Then I'm going to quickly, you know what, let's not do it quickly. I can just add to this test step here, let's add like a sleep command, because I want to like stall this pipeline. And while this is running, I'm going to push a new commit that will trigger another build, and then it will try to allocate an additional 7 cores of CPU, and it won't, the pod would not be able to be scheduled on any node, right? Because we don't have enough resources. This is where my autoscaler pod will identify this and scale a new node from it, right? So if I can quickly show you this in my cluster again, but I can run the get pods command on the cube system namespace, and I see my cluster autoscaler pod here, right? So it's constantly running and checking if there are any pods that are trying to be scheduled on some node, but there aren't enough resources. It will scale up and add nodes dynamically to my cluster. But it's also, we can even look at the deployment of it, but then let's do the get the deployment in the cube system namespace, and I can look at the cluster autoscaler deployment, right? Let's enlarge this a bit. So I'll grab the deployment name, and I'm gonna run the get deployment, add the deployment name, and let's do -o YAML, and you can see all the configuration options that I added here to my cluster autoscaler. So a few things that I didn't show you yet is that I added these scale down configuration options to check every minute if a scale down is necessary, right? Because if there are just too many nodes, sorry, and they're just not utilized, then we might as well just scale them down to save money. So let's go and I did make the change to my pipeline, right? I added this sleep command. Now let's go and run a new build. So I can then just go and again look at my Go file, make any change, and doesn't really matter what. Just remove the exclamation mark, and then run git add, commit the change, and add some commit and push. right? So this will now trigger a new build, right? And I can go and look at the builds here. I see a new build just started. Now, let's say another developer on your team goes and pushes another commit, right? So let's go and make another change. And just add something here to my app, and then commit the changes. And push, right? So let's see what will happen now. So now I can go back to Codefresh, see that the first build is already trying to, is already running, and it's now building my Docker image. By the way, you can see that it's using cache here, right? That's the distributed layer caching kicking in. And it now goes into the run step. And you see, by the way, when it tried to print out a secret, as I set this as a secret, we have a built-in log masking feature that won't show the value of the secret, even if I try to echo it out. That's even more secure if you don't want your users to try to just echo out secrets and having the values exposed. Now it goes into the sleep, right? So this will now take some time. And now I see that a new pod is trying to be scheduled, but this is still trying to validate against the Docker daemon, right? So if I, because we don't have any node, and if we go and run the kubectl get pods command on the CF namespace, sorry, there's that CF namespace, we see that we have one dint pod running. That's for the running build, but we have one pending. And it's pending because there's not enough resources in the nodes of the cluster to schedule this pod. So now what will happen is the autoscaler will kick in and will schedule a new node in my cluster. So we can actually do this and see get pods in the kube system namespace. And we can even look at the logs of the autoscaler, right? And add the follow. So we'll see what's happening here. And we see, then goes to the end of the log. And you can see here that I have a dint pod that is unscheduled, right? And then it's going to spin up a node because the pod just could not be scheduled. So I can go to my AWS console, refresh here, and I see that a new node just started here, right? I can even see when it happened, just about a minute and a half ago. And I can see this here as well, right? I can go and run the get nodes. And I see that now I have 4 nodes, right? I can remove the OY, it's a bit confusing. I have 4 nodes now. I used to have only 3. And now if I go and run the get pods command on the CF, I see that I have 2 dint pods running, right? So this is the autoscaler for you. So this first build, let's see what's happening here. First build is still stuck in the test step, right? Because we set it on sleep, but now the new build is already running, just finished building the image and then run into the sleep as well, right? So this is how like the runner works with cluster autoscaling. And if you are familiar with Autoscaler a bit, you saw that I didn't really do anything very special, right? The Codefresh Runner just acts like any Kubernetes application. So it works out of the box with Autoscaler, meaning that you don't need to have like a huge build farm like companies used to have with tools like Jenkins, for example, maintaining all these clusters and all of these infrastructure, because sometimes it would just be underutilized, right? So you can just have any Kubernetes cluster. It can be an EKS cluster, GKE, on-prem, whatever you want, and then you can have this autoscaler, and then it will automatically scale up pods nodes when needed. Now let's do this. Let's stop these builds actually, and we can then see the scale down happens. right? Because now I terminated these builds. I can then go and watch the get pods command on the CF namespace. I see these 2 engine pods are now terminating. These 2 ding pods will also be terminating soon. You see it's now terminating as well. And then I now will find myself with 2 nodes, right? And I don't really need 2 of them because I don't have any builds running. So now let's go and see what will happen to the autoscaler, right? So we can go again and cube system and look at the logs of the autoscaler. -F for follow, and now it should do the scale down. So you can also see it here. Check it out for the logs, starting scale down, going back to my console, and this node should now be terminated. So this depends on how you configure your scale down. You don't want to like run a DDoS attack against your cluster, right? So I think 1 minute is pretty much the lowest thing that you can put. And you see that my node is now being shut down, right? Because the autoscaler identified that it's underutilized. I don't really need it anymore. And it's automatically being shut down. And my cluster is going to revert back to its original state with having only 1 node for running builds. So that was it a bit about the autoscaler. Now, one more thing that you can see, and I told you I'll talk a bit about these dashboards here. So I can go here to the environments dashboard and I can manage my environments for Codefresh. So I see that this is my production environment. I see the last builds that made a change to it. I can see the actual output of the application from here. And I can then even see the services that are deployed as part of my production environment. So I have this Go application. I see the number of replicas. I can see, the status of the deployments, the pods, the replicas, and I can then manage my image. Even though it's an ECR image, I can manage it directly from Codefresh, right? So I click on the image. I see when this image was created. I see that it was then promoted to ECR automatically, by the way, right? This is part of the build step. I can also go and manually promote it to any other registry like GCR, Docker Hub, and add tags here. I can see the Docker file of my app. I can see all of the layers, and I can even then trace back the changes from this image that is already deployed to my cluster all the way back to the commit SHA that takes me to my GitHub repo and shows me exactly the change in my source code that eventually triggered this Docker build and this image that was eventually deployed to my cluster. So there you go, right? So if you now that you have both the CI and CD platform in one platform, you can easily understand for any of your deployments, any of your Docker images that are deployed, trace all the way back to the source code and see the changes. So if you ever wondered for a specific deployment, does it include my commit or it doesn't, then you have this here out of the box. And that's pretty much what I want to show here, and maybe we'll have time for a few questions. So going back to my presentation. Yeah, short summary. So we said that with Codefresh you can run with different offerings, right? You have the fully SaaS offering, meaning you sign up to the SaaS platform, but your builds are also running in completely cloud-hosted environments. You have the hybrid, which is what I presented today, meaning using the SaaS platform for managing your account and users and all that stuff, pipelines, but running your builds behind the firewall for additional security. And we also have a completely on-premise offering if you want to manage Codefresh entirely by yourself. And we saw that the hybrid can be installed on any cluster. We showed how to install it on simple Docker for desktop cluster, but also on an EKS cluster. and you don't need to open any inbound ports. You can access any secure assets, and you can manage multiple runners, multiple runtime environments in your account. So that's it. I think I have a question slide here, but I added it, doesn't matter. Yeah, ready for questions.
Awesome. Well, we do have numerous questions in the Q&A. If you all have anything that has come up, please feel free to enter it in the Q&A. We do have another 10 minutes or so here, so we'll make sure and get through all of your questions. So thanks, Guy, first of all, for that great presentation and for your live demo. That's always great to see. First, Charles says that he's currently evaluating hybrid behind the firewall, and he's found that he can't manage the Codefresh YAML in his own source repo. Is this something that's going to be available soon?
Yeah, this is actually one of the items that we're working on with highest priority. So currently what's happening is, if we go back to the platform, maybe just to clarify what you were talking about, sorry, going back to my environment. So I used github.com public and not public, but cloud-hosted repo. If you use a behind firewall one, then currently our platform tries to create the webhook and pull the YAML from your repo. But we are moving this functionality to the runner itself. So now, very, very soon, the runner would be able to handle all the interaction with GitHub in the sense of creating the webhook for the trigger, managing the YAML from the trigger as well.
Excellent. And Charles also asked, the Codefresh CLI is used to install the runner. Is or will there be a Helm version 3 deployment option?
Very good question. We just completed this today, and this should be released tomorrow, I think. And so, yeah, you saw that the runner, as you said correctly, is currently installed using our CLI, right? But we also created a Helm chart that wraps around the CLI, and then any flags or options that you can pass to the CLI will be available as values that you can pass to the Helm chart, and you can then install the runner via Helm if you prefer that. Should be available Excellent. Starting tomorrow, probably. Yeah.
Very timely. Excellent. And Jacob asks, is there a way to install the Codefresh runner to a cluster declaratively via Helm or Kubernetes YAML? So kind of similar.
Yeah, so we just answered that. So yeah, should be able to do that using Helm starting tomorrow, hopefully.
Excellent. And let's see, our next question is from Ryan. Does each step in a CI workflow run in a single pod, or does each step spawn a new pod? The reason why I ask is because we have a situation where we'd like to customize the resource requests and limits for a particular step in a workflow.
A very interesting question. So as I showed in the demo, currently what we do is for every build, right, every full pipeline workflow, we start one pod of type dint, right, Docker and Docker, and then every step in the pipeline runs as a container inside the same pod. So as for your question, no, every step runs inside the same pod. Not every step runs in its own pod. And we do understand the use case, definitely. And this is also on our roadmap for 2020 to kind of refactor our engine to support by the way, not only Docker and other native container runtimes supported by Kubernetes, but also run every step in its own pod, and then having the flexibility to run different steps on different clusters, different namespaces. One thing that you can do right now, however, is that you can use the Codefresh run step type. Let me show you what I mean here. So for example, say I have this pipeline here, and I can look at some build. So you see this is like a full CI/CD pipeline that starts with cloning some repo, building some Docker images in parallel, pushing all of these to some Docker registry. Then it will start the CD flow. And the CD flow will first deploy some thermal environment using Helm then move to staging, and then move to production. After each of these deployments, I want to run a set of deployment verification tests. So instead of explicitly listing these in the same huge pipeline, you can use the Codefresh run step type to trigger other pipelines from your existing pipeline. So what you can do now is, let's say you said you want to run a specific step on a different environment, right? You can install multiple runners, and then you can have like a separated pipeline for this step, and you can configure this pipeline to run on a different environment. It can be a different cluster, different namespace, different architecture. And then, you know, the main pipeline will call it out, but as a different pipeline for now. Hope that
Excellent.
makes
And I
sense.
answered a question earlier in the chat, but I just wanted to reiterate for everyone. Someone asked if the Codefresh Runner is available on all subscriptions, and the answer is yes. Codefresh Runner is available on our free tier as well. So you can sign up for a free account, and the Codefresh Runner is available to you. And on that note, I just want to launch our poll as well. We're going to continue to answer questions, just asking for some quick feedback from everyone on what you thought of the webinar, and if you want us to reach out to you to help you get started with the Codefresh Runner. And let's see, our next question is, will Google KMS and Google Secret Manager be supported?
Very interesting question. So, and the answer is yes, but a bit on that. So what I showed earlier that I used is our new secret store feature in the account settings. And this is currently supporting either Kubernetes secret or config map, where you can easily fetch any of these behind the firewall secrets and use them in your build as environment variables. We saw, like, inside the pipeline, right, that you have all the built-in steps that you can use. So if we look at the workflow here, you see all of these steps. You can see also all of these steps if you go to codefresh.io/steps. And here you will see that we already have an integration with Google KMS, also with HashiCorp Vault, and also with AWS Secret Store. And you can use these right now, right? So yeah, like fetching secrets from AWS Secret Manager, fetching secrets from HashiCorp Vault. The thing is that these integrations are currently as steps in the pipeline. So you can just place this step at the beginning of your pipeline, or just before, you know, you want to use these secrets, and then this step will read secret and export them to be used in any subsequent steps. So again, you can use Google KMS, you can use AWS Secret Manager, you can use HashiCorp Vault, and there are also some examples on that in our documentation. So if you go to our online documentation, you search for Vault secrets, it explains how to read secrets from Vault and use them in your pipeline in Codefresh.
Excellent, thank you. And our next question, can Hybrid Runner deploy onto AWS Fargate EKS?
Definitely, yeah. So this is also something that we have as a built-in step supporting. So you can go again to the steps here. And if you go to the deployment section, by the way, most of these steps were actually contributed by our community of users. We have a built-in step for deploying to ECS, not only Kubernetes, even a blueprint deploy to ECS. And if you go to our documentation and go to the deployment section, you'll also see deploying to Fargate, ECS, with a native step. So as for the deployment destination, it's not only Kubernetes. The runner does need to be installed on a Kubernetes cluster, but you can run your builds on a Kubernetes cluster and have it deploy to an ECS or a Fargate cluster.
Excellent. And next question from Andy, can the runtime settings manage in YAML instead of using UI? Which I think.
Mm-hmm. Yeah, pretty much everything in Codefresh can be managed as code. So if you go to our documentation again, you'll see here in the top, there's API, there's CLI section. So you can then see that you can define the whole pipeline configuration spec as code, as YAML, not only the steps in the pipeline, also any variables that you want to use, the Git triggers, any metadata you can configure it out all as the inside this YAML spec. But even for the runtime environment itself, I can use the Codefresh CLI to run like Codefresh get RE. RE stands for runtime environment. Then I can see it's my EKS runtime environment, and I can go and see the actual YAML for the runtime environment here. I can manage it from here. I can add any environment variables to the Dint pod or anything like that, but with a bit more advanced use cases. But yeah, it doesn't have to be managed from the UI. You can use it from the CLI or API.
Excellent. And our last question, we're just about at the top of the hour. Jacob asks, if his account has a limit of X concurrent builds, does that apply to hybrid run jobs?
Yeah, good question. And you can go and see our public pricing page. So you'll see that indeed one of the main factors that affects the price or the plan in Codefresh is the number of concurrent builds. So basically the runner is an enterprise feature, and depends on your license, you'll get X amount of concurrent builds on the runner. But because we wanted to let our basic and pro users play with the runner as well, we provided the ability even for free users to run builds on the runner with one concurrent build. So if you are on a free plan or a basic or pro plan, you should be able to run up to one concurrent build on a runner. And as for any other SaaS runners, then that depends on your plan.
Excellent. Well, again, thank you so much, Guy, for that great presentation. Thank you, everyone, for joining us today. Please check out codefresh.io/events for all of our upcoming webinars and now virtual meetups. And we hope to see you next time on Codefresh Live. Thank you. Have a great rest of your day.
Bye.